Hello, everyone, and welcome to our 2 o'clock presentation. Your trailer is your foundation. My name is Laura Moss. I'm the Board of Directors of Yes Tomorrow Design Build School, and it is my absolute pleasure to introduce to you Keith Lewis and Jacob Mushlin.
Hey, hi. Hey, thank you. We're going to share the mic as much as humanly possible. Before we get into it, I want to reinforce a couple things. This conversation has the opportunity to get very technical. If you don't understand something, stop us. Ask us to explain what we just said. We're going to try to keep it open to the layperson, but like headline, if you don't understand what we're talking about, either we shouldn't be saying it or you shouldn't be here. So please raise your hand and stop us. We're going to talk a lot about moisture and movement and shear. And while these are very dry topics, we're going to try to keep it as exciting as possible. We'll hopefully open it up to individual questions at the end. And other than that,
real quick, my name's Keith, and I'm an instructor at Yes Tomorrow as well as a home builder. I do custom design build homes, not so tiny houses, but I've been working with this gentleman here, teaching at Yes Tomorrow the tiny house design build course for the last 4 years. So this has been evolutionary for us as well as builders. I'm used to building structures on concrete that are embedded in the earth that don't move. One of the most exciting challenges of the tiny house course is thinking through that structural integrity of your home sitting on your trailer. So, starting off, this is really one of the first projects that we had done with Yes Tomorrow, where it was a tiny house trailer designed to have tiny house on it with a floor system that rested on top of the flanges of the actual trailer. There's a deeper depression in the trailer that we insulate and prepare it for the structure. So one of the most important things is that obviously our trailers are made of steel, so they're highly conductive. So think cast iron skillet on a stove. If you've been cooking with it all day, you go to grab the handle, you're going to burn. You need something to protect it. So that is true for both cold and heat. And one of the things that, especially here in New England, where we're experiencing extreme weather conditions outside and trying to maintain a comfortable environment inside, we have this transfer of warm and cold that are meeting one another and creating condensation on some of these solid surfaces. So we do our best to insulate to try to separate those two environments. This is a trailer of a most recent project that we did that was, in my opinion, very well designed to support a tiny house based on the way that this flange, I don't really have a cursor. This flange is going to support our wall system all the way around the building. There's a 5.5-inch cavity that we put a pressure-treated floor system in, and we used a rock wool insulation that is capable of handling moisture and moisture content, because it's going to get in there. There's really no way to keep it out. It's a natural occurrence. So we try to think through this process, trying to keep as much water out as we can with flashing and adhesives, so on and so forth. But we also have to plan that just being in the environment, being in the atmosphere, you're going to experience some condensation. So we like to use materials that are able to kind of deal with that moisture and allow it to release over time and won't create things like mold.
real quick, one fun fact I like to throw at people about what it means to build on a trailer. What's the first thing that a tiny house on a trailer will experience the day it's born? Like a half-hour earthquake and a half-hour hurricane, right? Because that thing is traveling down the road. That's asking a lot of a building. And there's often going to be not only considerations in the trailer itself, but in the whole structure that are going to look atypical to what we think of when we build houses that aren't built on trailers. So just, I want to like plant that seed, that get ready to let go of, forget everything you thought you knew about building, because we're on a trailer now. Yeah, what's up next? Next slide, and I'm going to hold the mic, and we'll see how this goes. So, couple things. When Keith and I first started building on trailers, they were not intended for tiny houses. The trailer was, you know, just a trailer. The fenders typically like came up 2 inches, shot at a 45-degree angle for a little bit, then leveled out. And for the sake of like cleanliness, they always had a curve in them. And if all of a sudden your job is to like have wood meet that, it's actually a huge pain in the ass. There's all this weird stuff going on that isn't helpful for you. But again, this trailer wasn't designed to be built on as a foundation. However, a lot of things have changed. This was the first trailer we worked with that had this funny little detail that made it a little bit easier for us to build into. I still kvetch a little bit because it wasn't rectangular. A lot of the fenders nowadays do just come up at a 90-degree angle. They shoot across to cover up those wheels and they shoot back down. Super easy to build on. It's all 90-degree stuff. I don't know if anyone out there is a builder, but like in general, 90 degrees is a breeze. This one has this funny little curve. However, that vertical edge that sort of pokes up, you know, before we were talking about flanges that came out across, this one shoots straight up. That was like brilliant for us. We could bring all of our sheathing and material to one side of it, and then our tapes and our flashing and all the stuff we use to shed water could capture that. So now as water ran down the side of the building, the same way my shirt is sort of that water control level, that flange tucked underneath. So all that water could just run past. It was pretty slick. If you're looking for trailers, that's a nice little detail. That's my butt. We were talking about the flange earlier, so feel free to come a little closer if you want. There's a little bit of seating. We don't want to block the camera. But this trailer is made out of some tube stock that's 2 inches wide and 5 inches tall, if memory serves. And welded onto that is like a 3-inch horizontal flange and like a 2-inch vertical flange. And all of our wall is on that flange, supported out in space. Structurally, not a problem. Totally cool. We're on it. As far as what Keith was talking about with thermal transfer, it's actually a little suspect, right? If you walk up to in the middle of winter, go and touch your window. The glass on your window is really thin, and it conducts heat and cold very readily, right? So you touch it, and it's really cold. Touch the wall right next to it, which is way thicker, which has insulation, which is maybe made out of wood, and it's way less cold because that wall is a much better barrier to those things. It is not as good a thermal conductor. So before we start building and just putting our wall directly on that thing that has like minus 14 degrees on the underside of it, maybe we build, like we saw in the, I think, first slide, we build a deck right on top. Can you zip back real quick? Yeah. See, and there's one of those square fenders I was telling you about. But by building this up, we have broken the thermal bridge. There's a lot of framing in there for sure, which isn't stellar if that's your goal. But it's more than nothing, and nothing did not do much for us. So on top of that, we'd be framing up our wall, and now we have a little bit more of a thermal break.
So one of the prescriptions we came up with for this particular trailer, this is a very thin layer of a polyisobutene styrofoam that has a fiberglass layer over it. Likewise, in utilizing that floor decking, now we're separating, making a continuous separation between the bottom of our floor system and the trailer. Now, one thing I wanted to point out, this trailer sat outside, although it was brand new, hadn't been built on yet, it sat out for a little bit. People were storing some things on it, got a few scratches. Doesn't hurt, get yourself a can of Rust-Oleum, go around and just hit up those little scratches because that moisture over time is going to get in there. It will create rust and it will rot from the inside out if you're not careful. So a few minutes with a spray can, going around anywhere that we marked it up, cover that with a little bit of spray paint, and you can continue on with your building. One of the things that was unique about this trailer is that our floor system could sit completely within inside the trailer, be insulated, and bolted through these little holes you see on the side to the tube steel, making that floor structure now completely connected all the way around to our trailer. Our flange system was separate, but we included that same styrofoam layer up the sides. No, I guess I didn't capture that. So It's just simply a thermal break. You're going to get wind and air flowing underneath your trailer, so it's important that you try to put as much insulation in there as possible. And in this case, we had 5.5 inches of space. One of the things about these fenders and building around these fenders is that on your typical house, you have a bottom plate and a top plate that's tying to your foundation, which is tying the wall to your top plate, which is holding onto your rafters, so on and so forth. They all overlap one another. When you have to build around these fenders, you are now interrupting that bottom plate. You're interrupting the structural integrity of the bottom of that wall. So you have to actually plan ahead for that. We're going to have to, where we make that break, you can kind of see in this slide, we've put in a header, which is supporting the weight of the rafter structure above, because we can't actually build off those fenders. Those aren't structural. They're there to keep water from blowing up into your structure or getting anything wet, protecting whatever you have on that trailer. So we're not putting any weight on there. We're just building around it. We're going to carry that weight over top of the fender, and then we're going to use some really sexy components to connect your walls to this trailer. This is a Simpson HTT4 hold-down bracket. It's pretty basic. It's only about 20 bucks. We put about 6 of these in every trailer. We put 1 in all 4 corners, and then, oh, actually it's 8, and then 1 on each side of the fender. And what that's doing is creating a space. We'll drill a hole through the floor system, through the trailer.
Boom.
Look at this guy.
As best you can. I wish we had a dry erase board. Thanks for dealing with what we got. So, wow, this is going to be funny. You're so welcome. I'll just kind of keep doing the spray as we go. But, oh, look at that. See, one hand washes the other. Right to the chest, if you don't mind. It's just going to be better. There we go. So, way over here, that's the flange we were talking about, right? That's that L of metal that hangs out into space. This rectangle is that rigid 2x5 tube stock. That's really the structural integrity of the frame itself. Built on top of that, what you saw in that's the deck that we frame on top. And that's just so when it's minus 15 degrees out here, that cold has a little bit more of a path to take before it gets into living space up here. Does that make sense? Now on top of that, just like it's any old platform, we're now framing with a bottom plate like Keith said, and there's a stud. And this handsome devil right here is that piece of metal. And you can see that that piece of metal has a bolt that has a hole that goes all the livelong day, even through that flange. And now you have what we'd call a very positive connection between the walls of your building, the floor of your building, and the foundation of your building, which happens in this case to be a trailer. Yeah, it's pretty sweet.
What do you call that piece again?
This is they've been called a hold-down bracket or a tie-down bracket. So Simpson is a company that makes all sorts of different kinds of hangers and fasteners to help us connect wood to wood or wood to other metal components. And what that's doing is giving us more connection between our wood members and our trailer. What I like to call it is really sleep insurance, because this is something, as I build for other people, these are the types of things I worry about. So going back to what Jacob said, experience your building as you move it from site to site is experiencing both hurricane and earthquake conditions. So if you're driving 65 miles an hour down the expressway and you have a headwind now of 65 and you get a gust of wind 40 miles an hour, you're somewhere between a hurricane or Category 1 and a Category 2 hurricane. I see there's a question here. So what the question that was asked was how much insulation did we put underneath our wood floor deck system? We only used a 1/2 inch for a thermal break. All we're trying to do is create a continuous break between that insulation. So we like to use a rigid foam, something that's dense and can take some weight. This is really just kind of like, how could I say? It's more like the sheet in your bed is the first layer over top, and then we're going to add layers for actual warmth. So in our floor system, we have additional layers of insulation that we added to this system. So the real importance of these hold downs is that when you're making those traveling transitions between wherever you may be going, you're not relying on just the wood sheathing to hold the skin and the bones of your building together. Because when you travel over that bump, and your truck goes over it or the truck goes over it, and the trailer's in tow behind it, you're creating a whiplash effect. And now all of that weight from your building, as it goes over the bump, is slamming down onto your trailer or onto your foundation. This is going to help spread that force overall. And especially where you have interruptions over your wheel well, this is very important to have for making a safe transition with your home.
Do you have any other slides? No was a great answer. So, some cuties.
Shows some of the locations. You can't see it very well, but in the corner we have a hold down bracket here. You'll see up top, we're talking about these Simpson. These are joist hangers, rafter hangers, or hurricane ties. You can see up in this window, you'll see a metal bracket in the wood corners. When we have very large window openings, we don't want to rely on just our nails, especially when in travel we use these header brackets that will grab onto the stud and will grab onto the header that's holding up the weight. And the reason we do that is that windows they're not necessarily structural. They're not holding your building together. They're just separating these environments. So we like to go above and beyond for that sleep insurance, adding these brackets in so that when we know this thing travels down the road, it's going to still be in one piece when we get to the other end.
And I'm going to make the decision to confuse you a little bit right now. Yeah, so we talked about thermal bridging and how we want to cut down on that to keep the cold further away from the inside. However, every stud, every piece of wood that touches one side of your wall on the outside and the other side of your wall on your inside, that's also a thermal bridge. The insulation cavity, the void in between those studs, that's what you want. So you'll often try to minimize framing. Some folks call it advanced framing. Really, I think of it as framing 24 inches on center rather than 16 inches on center. And if none of that meant anything to you, you're in the majority, don't sweat it. But things like this bracket are one of the tools that we implement to be able to do that advanced framing in order to try to cut down on the thermal bridging of a wall. Oh, great. Yeah, we got that. So we can see, like, right there is one of these handsome little devils. And that's saving us 1 or 2 vertical studs in that wall that otherwise would need to be there as a shelf to support the structural header on which it would rest. We have about 5 minutes left. I'm totally open to taking questions unless Keith has a very important thing he wants to add.
One important thing I want to add is actually if you look at at the end of the day, what is it you're going to be leveling your structure out with? These jacks that are fastened already, welded to the trailer. This is a cylinder-style crank jack. You've seen different ones looking around some of these trailers. There's a scissor lift jack, if that's the right word for it.
Like when you're fixing your car, it's got the little scissor one that folds flat.
These are really important when you're buying a trailer. That's something that I would actually look at first. One of the first things I would look at, what is going to be leveling this trailer out and really holding it up and keeping it stable over the course of the time that you're spending living in it. In some cases, if it's going to be in permanent location, I'd go as far as to maybe pour a concrete slab, put an anchor in it so I can actually anchor my trailer to something else. That was really the only other thing I wanted to point out as far as trailers go, other than make sure that you understand the weight of your trailer, how much that trailer can hold, Those things are really important, especially if you're getting creative and you find some reclaimed piece of granite slab you want to put in your kitchen. You know, you got to think about weight and make sure that your foundation is designed to hold that structure that you end up with in the end. And from there, I suppose we could go to some questions if you're interested.
So first of all, a gooseneck trailer is the type that instead of connecting to the ball on the back of a truck, it actually has this armature that comes over and connects like to the bed of the truck, like in the middle. Gooseneck trailers are awesome. I normally see them creating like a loft space right out of the gates. There's a really lovely couple that may or may not have their tiny house here now. I think it's one of the only goosenecks I've been in, but they did a bang-up job. You walk through the main body of the house, and then you sort of transition up these steps that's also kind of the bathroom and the closet, and they have this great bedroom up at the top. There may be other considerations. I've never built with one. I don't know if you have, but I'm for it.
Another question? Yes? So the question was about tires and axles. So the more axles that you have, the more weight you're going to be able to carry and the more stability that you have. Tires, it's not quite like your car that you're using and driving with every day. I don't have a specified brand or type of tire that I would recommend. They can get dried out by the sun, and one of the reasons that these jacks are important, and one of the things I'd also potentially use is an auto jack, to where once you got a location where it's going to live, I would take that pressure off of those tires and rely on those jack stands to create your stability. And that's one way that you can reduce any wear and tear or dry rot on those tires.
Regrettably, that was our last question for time. I know I'm happy to make myself available as we make our leave to keep attacking us. One quick side note, you could also cover those because UV is going to try to mess with those a whole bunch. So if you do have, make a cute little box and put a planter on it. It's going to be great. You could skirt all the way around so cold wind can't cut underneath, but if nothing else, just make like a 1, 2, 3, 4-sided thing that covers those wheels. And that's the last thing I'm going to say about that. Thank you so much for your time and your patience.
Thank you very much.